All right, hello everyone. Very excited to be here. It's a really cool topic, so I just want to dive straight into things. So I do a bunch of battle videos with GamedevTV, where there's someone who represents Unreal and Unity and Godot. And so I'm fighting the good fight representing Godot engine, making sure open source looks great against its competition. And so the battle video that led to today's talk was talking about how to make a bullet hell with only one script. And that's kind of a cool topic. That leads you to think about a lot of things. Like you could have one script on your player that interacts with all of your enemies and makes all of them move and sorts out all of the interacting parts of your game. But I needed to find some way to take this further so that we looked just, well, so that we could show how good Godot can be in the face of the competition. So the video did come out. There I am on the left, and so I did come up with something. Okay. So these videos have a certain amount of prep time. We get about a week to plan all of this stuff, and then we get to record it in 1 hour, which is another hurdle to also jump over, because we need to have prepared something that we can then perform quickly, which isn't easy. So the ideas I was working with, I knew there were lots of games in Godot you could make with a very limited script. I've seen people make like survival-like games with one line of code. You can do some really impressive stuff to bake your code golf down to a really short amount of time. But I wanted to find out if I could take that further. Could I take that to an unnatural extreme? And could I make a game with no code? Could I make a project that had no script files in it at all? And not cheating, not using like a visual scripting alternative, just doing everything by having nodes and plugging the signals that come out of them into the various functions of the other nodes you've got. So that's what we're going to work towards. I'm just going to introduce myself quickly. My name's Bram. I have a YouTube channel where I've made stuff about shaders and introductory tutorials. Historically, I worked at Feral Interactive. I worked on the mobile port of Rome Total War. It was around then I started using Godot, because I only had a Linux laptop at the time, so that was good. And after that, I worked as an engineer in test at Cisco before making educational material with GDQuest, and then my own courses on itch.io and GamedevTV, and now I'm releasing a game on Steam called Gothic Steel. And I've been in a bunch of these game jams, so a couple of these were pretty good ones I was in. So is it possible to make a game with no script? We're going to need to answer some hard questions. We're going to need to figure out things like, can you get input from a player? Can you you don't have access to a script with the input singleton. How are you going to listen to these keyboard presses? If you can listen to keyboard presses, how are you then going to move the player around? That's tricky. How are we going to spawn enemies? If we spawn enemies, can they spawn projectiles? Can we connect those projectiles hitting us to signals and functions that will actually do damage to us? Can we track health? Is storing variables something that's possible? Can we restart the game? Can we quit the game? This is all stuff trivial, well, not trivial, but you can do it with the script. So I came up with good solutions to some of these. I came up with bad solutions to some of these, and I creatively avoided the rest. So let's start with the first hurdle. I think if you're thinking about a way to make a game without a script, you're thinking about how we're going to get these input events. If we were starting a project normally, a neurotypical approach to handling inputs would be doing something like having a physics process function that listens to the input singleton. It calls some kind of function to get inputs you've set up in project settings, gets you a variable back, and lets you in some way use that variable to move your player about. That's a typical setup. As said, we don't have an input singleton we can access without script. We don't have a position we can add values onto. We don't have variables. We don't have a physics process function. We don't have a script file. So we need to think about the things we can do. And Godot has a bunch of nodes that let us interact with Godot without a script. If you think of user interfaces, you might be thinking of adding a button to your project at this point. A button is something you can click on, and it has a press signal that comes out, and you didn't need to connect anything for that, so that's probably a good starting point. So what we can do is we can make some buttons. If we have a simple version, we might have a move forward, move left, move right, and move back button, and just have them on the screen and let the player click on them. But that's pretty unsatisfactory. We'd rather use keyboard inputs. But thankfully, Godot's so prototyping oriented and so good at reducing the code we use that people have made some features already on buttons that mean we don't need to do any of the script part to trigger these button presses. If you go into a button, you can add a shortcut to them. And a shortcut is a resource that lets you bind an input event to triggering the button. So we're now already in a spot where we can put a shortcut on a button, and now we can make it so that the W, AS, and D keys push this button. And these shortcuts exist because it's a common problem you want to deal with. If you were in an RTS or something, if you imagine you're playing StarCraft, you'd have a bunch of buttons at the bottom of the screen that were for different modes for your units or something, like attack mode or going into build mode, and you'd want to be able to trigger those buttons with key presses, like the B key. So they made a shortcut so you can do that because it's a common problem in your projects. So we end up in this spot where we can have these 4 buttons. We can have our move up, move left, move down, and move right buttons. And then you can see they're being triggered because I'm pushing the keys on the keyboard. So now we're in the spot where we've got inputs we're technically listening to in a mild way. And we want to, we want the pressed signal that comes out of that to start moving a player, which means we're going to need to make creative choices about our player so that they have functions that will be able to move them around based on this pressed signal. Thankfully, you can connect functions to any, you can connect signals to any of the functions that are already in your project. So there's, in the edit connections window, you can connect a signal directly to a function that's on any node without needing to go through a script. So if you had a function on a node like Q3, you could plug the press signal directly into it, but you just need to know the toggles that hide it by default. So I'm going to do a simpler example. I'm going to do an audio stream player, and I'm going to have its finished signal call Q3 on itself, so that we're broadly getting the functionality you would want from a script. So if you've added an audio stream player to your project, you get a finished signal that comes out. If you've got it selected in the scene tree, you could look over to the inspector and right-click on it and connect to open this connector signal to a method dialog. When you're in there, what you can do is you can click this pick button in the bottom right. I think at this point, you'd usually just click on a node with a script on it and click connect and let it create a function for you dynamically and put all the code in there that you want to actually do whatever you want the button to do. But in this case, we need to find our function we want to connect to. So you can click the pick button. And when you're in there, there are these toggles down at the bottom that let you show internal scripts. So script methods only down there. If you uncheck that, will show you all the internal stuff. And compatible methods only is another important one, because a lot of our signals aren't going to be compatible with these functions we want to try and call. But here you can see we've got our finished signal, and it is calling our Q3 function. So now, whenever our audio stream player, it deletes itself, and we're imitating having a script. So we need to use that by making our pressed signal call a function on our player that will move them. So we need to call a function that moves our player. This takes something like a character body off the menu, really, because a character body, you need to set its velocity every frame, call the move and slide function, all of that stuff, and that's tricky. There are ways, people came up with good ways in comments, but we're not going to do that. We're going to take the easy way out and make our node for our player simpler. What we're going to do is we're going to have a rigid body, because rigid bodies have a function called set linear velocity that lets you set the linear velocity for the rigid body. So if you set it to 15 meters a second forwards, you can end up in a spot where pushing the W key calls this button that sends a press signal off that will send the signal to the rigid body that calls set linear velocity that sets it to forward, and the player will move without a script. That's the good starting point, I think. So we just need to figure out how we're going to make the set linear velocity pass in the direction we want, because at the moment our press signal sends the signal out, and there's no data attached to it. Thankfully, that connections window I was looking at earlier that had things hidden behind toggles has another toggle that hides another window, and that window lets us bind extra arguments onto signals. So let's have a look at that. If you look in the bottom left, there's the advanced toggle. If you toggle that on, you will get this add extra call arguments section on the right that lets you bind any variable you want to go into whatever function you're connecting it to. So now we can add a vector 3 onto our pressed signal, and if we have it set to z is -15, that'll mean we'll have a direction that's going 15 meters a second forward. And The press signal will start to make our character move 15 meters a second forward. We just need to connect it after we've set that up. So yeah, this edit connections window, having a lot of depth, is what made half of this project possible. I don't think Unity or Unreal came up with an equivalent. It looks like this. We've got a player. When we hit WASD, they move around, and we can put particles on because they don't have a script, and then it makes it look a bit prettier than just having a mesh moving around, because it's not rotating, it's a sort of pale imitation of regular movement. Okay, we've got a player and it moves. What else do we need to make our game work? We need obstacles that when we hit, we get hurt. So what we can do is we can make things that are moving around and make them and detect coming into contact with them. I'm actually going to start in a bit of a more fun area than detecting contact. I'm going to make them move around because that's kind of how I'd make it in a normal project anyway. What we can do is we can use an animation player, because the animation player is the other powerful thing that lets us pretend we've got a script as well, because it can set variables and it can call functions. So animation players are great because they do so many things. They can set properties on lots of different nodes at once, and they can call functions, and we can trigger them with signals. Animation players are just great. You can also have animation players control other animation players, which is really helpful. That lets us palely imitate having more functionality than we have as well. So in order to make our enemies move around, we can use a fairly common pattern in 3D games where you want something to move along a preset path. What we can do is we can make a path 3D. That lets you set up a Bezier curve, and then you can have a path follow 3D, and that will move itself along the path 3D. So it has a progress value that goes between 0 and 1, and when it's 0, it's at one end of the path, and when it's 1, it's all the way at the other end. And we can use an animation player to interpolate that from 0 to 1 over time and make our enemy move along this path. And you get something a bit like this. You get this simple setup with a path 3D, a path follow 3D, a rigid body, and an animation player, and you get an enemy with GPU particles that moves from left to right. So we want to take this point and we want to build it out until we have more complex things to dodge. I think that's easy to dodge at the moment, even with our very simple player character. So what we can do is we can copy and paste it 11 times, and we get something, we get copy and paste it 11 times, and we can have a new animation player that triggers each of the animation players within those individual paths. And now we can sequence a wave of them all going from left to right, from top to bottom, and you get something like this. And you can swap the animation player you're playing out, you can swap the animation you're playing out with right to left instead of left to right. And you could start doing just the back ones all going at the same time, or all the front ones, or you could create negative space in the middle. And that's enough that you can start sequencing a whole level out, because you can now create a third animation player that controls the second animation player, that controls the 11 original animation players, and makes them play this animation, then wiping the other way, and then just doing the top, and then just doing the bottom. And you can build 2 to 3 minutes of obstacles to avoid. Unfortunately, avoiding them isn't important yet, because we've not hooked up anything detecting when we collide with these. So we need to figure that out without any code next. So in order to check for collisions, we'll do that like we would with a script, actually. We can add an area 3D, and it's got body entered and area entered signals that tell us when we enter those areas. So we add an area 3D to our player, and we can have it detect when these enemy bodies come into contact with that area and a body entered signal pops out. Of note, when you're doing a setup like this, it's important to think about how many connections you're making. Because if you have areas on all your enemies instead of on your player, you're going to need to set up connections from the enemy's areas to whatever it's triggering, like an animation player saying you've been defeated. And if you're setting up 11 of those, it's really a lot of work in a way it wouldn't necessarily be if you were using a script. So we've used the advanced connection window before to bind extra arguments. We want to do a similar thing here. What we want to do is we want to take our body entered signal and we want it to send that off to an animation player and make it play. But there's a reason that doesn't just work out of the box. It would with a script. So let's think about what we're doing here exactly. We're taking a body entered signal that has a body as a parameter. That's the one argument it's got at the moment. And we're trying to plug that into an animation player's play function. That's expecting us to pass in a string, and we're passing on a reference to a node. And it's going to crash. It's going to humbly say, I don't like the data you've given me, I reject it. So what we want to do is we want to take our body entered signal, and we want to discard the argument it has. We want to discard the reference to the node, and then we want to have this fresh signal, and we want to bind the extra data onto it, the name of the string for the animation we want to play, and send that into the play function. We think we can do both of those. We know we can bind and unbind, but Godot won't let us do both of those at the same time. What you'll find is if after you unbind an argument and you try to bind another one, it will gray out the subsequent window, which is a problem. Because we know we can do both, that means we just need to find some way that we can do those steps one at a time rather than all at once. And we're going to need to do something I'm going to call signal laundering, where what we're going to do is we're going to take our dirty, already used signals, discard them, and get a clean signal with no unnecessary data on it that we can then have call the play function we want. So how to launder signals. This will come up a lot. So what you need to do is you need to unbind an argument from the body entered signal, which we did in the edit connections window earlier. After that, we need that signal to call a function on a node that will cause itself to emit a new signal. So you're going to need to start thinking of nodes that can have a function called on them and then make a new signal come out. After that, we take the signal that came out and we bind the name of the animation we want to play onto it, and then we're off to the races. We can have our animation player play. So there is a short list of nodes that you can call a function on and make a new signal come out, and there are two good answers. Okay, there's one good answer and there's one less good answer. The good answer is to use a timer. If you have a timer, you can call it start function, and then after a certain amount of time, the timeout signal will come out. So provided you're happy having a 0.05 second delay between all of your signals being emitted and then getting to their destination, you can launder through a timer. It's only a bit of lag, it's fine. The less good answer, but still funny, is to use an audio stream player and play a really brief audio file. I vote for using an ant sneezing sped up 20,000 times, something imperceptibly brief to the human ear. But with this timer set up, we are now in a position where we can do what we want. Whenever our area touches one of these enemies, we can have a body entered signal come out, send it to a timer. The timer starts, the timer finishes, a new signal comes out, it goes to an animation player, we've bound the name of the animation we want to play, and our animation player plays. With that, you can make a whole game with no script. This is how it looks. We've got an area entered goes to a timer, timer unbinds, timer timeout happens, we connect it to whatever we want, including binding the name of the animation player we want to play. And now, now whenever we move around, if we go and we come into contact with this flag, winning the game is fundamentally the same as losing the game. We just cared about touching something here. But when we touch the flag, we get our signal coming out, we launder it, we turn it into the animation player saying, you have won. So you can make a game with no script at this point. For the battle video, I think that was enough to look the coolest. Anything from this point on is pure hubris. So how are we going to track health? This is going to involve us having a variable. How are we going to do a variable in this kind of situation? How are we going to increment or decrement it? There are just so many problems with this one in particular. It's real agony. There aren't many functions already on nodes that let you make a value go up or down. If there are, how are you reading them? Binding our extra arguments in the edit connections window doesn't save us here like it does elsewhere. Whenever you bind something, it's a constant rather than a variable, so you can't bind variable values to go around. It's just weird. And then when we do store a value, how are we going to read it? We need a signal to emit that cares about the value, that we've got functions that care about incrementing. There just isn't a good fit that exists for that. So you can only really, if we don't have a signal that comes out automatically, if we want to process it, we need to create something that like polls this node and tells it to emit new stuff. And at that point, we've created a clock in a computer that is regularly telling it to do stuff. And I fundamentally think if you're building a computer to solve this problem, you've gone too deep. So I did come up with a way to store variables, and it's bad, it's not good. I don't recommend it for any practical game. But the community then found a better solution. It's staying in the slides because it's really funny. What we can do is we can store variables in physical space. so we can take the 2D engine that's running at the same time as our 3D game, and we can use that to store values. So please look at this Jenga tower. What we've got here Thank you. So what we've got here, if you look at the red block, whenever that falls into an area, it sets the health bar at the bottom to a new value. And when it gets to the end, it says you lost at the end. Many problems here. They're areas, that means we need to launder the signals that come out of them. So in addition to the time for it to fall, it then needs to start a timer and then have that timer time out to send data on. If you're using physics with the floors to move them in and out, if you knock the block out of the tower, you become functionally immortal. So that's the bad answer. The better answer, as with all good things, first of all, it's animation player based, of course it is. And second of all, the comments found it, because of course they did. If you have an animation player and you set it to manual playback, you can call the advance function on it, and then it will advance a certain number of frames whenever you call it. So you're kind of using the progress through the animation player as you're falling down by gravity in a way. But that lets you do what looks so simple but is agony, which is pushing a button and having a variable value change. So there's only one more addition. I think we've not gone crazy enough yet. I think our wax wings can get a bit closer to the sun before they melt. Let's try and generate random numbers. In order to do this, we need to find some kind of nodal resource that can do something random, which isn't trivial. There's only really one answer, and that is to use an audio stream randomizer. So if you have an audio stream, there's an audio stream randomizer resource that lets you supply a bunch of audio streams and makes it so that whenever you play, a random one gets picked. So what we can do is we can make a blank audio file that's 1/3 of a second long and 2/6 of a second long and a full second long, play it at random, and we get a signal a semi-random amount of time after the audio stream player started. Yeah, it's nuts. So now we need to turn a signal happening at a random time into playing a random animation on an animation player. And for this, we need a magical device. And I like to call this device the randometron. What we've got is we've got a ball moving along a track at the top, and whenever a signal comes in, it tells the remote transform carrying the ball to release, and it will drop into a channel where there's an area, and when the area gets touched, we start a timer, and when the timer is finished, we've laundered our signal and we can start an animation. But this fundamentally lets us make our animation players pick a random animation to start with. Which, you know, it's just cool. If we wanted our enemies going around our level to look different every time we played, we could have one of these for all of our different waves, and then use them to pick which different wave type they were going to do. But with that, we are done. You can play it on itch. There's no script file, there's no GD script, it's all just animation players, signals and functions. You can pick different difficulties. There's loads of particles because they don't have a script on them. You can dodge lots of patterns. While I was doing the video, Rick kept saying it didn't look enough like a bullet hell, so I kept adding more and more bullets by duplicating my uber animation player until we ended up with way too many for me to manage. I even added an extra path that's going to do a loop-de-loop in a second. There it goes. Yeah. But yeah, the comments were kind too. Man made a game in Godot with Redstone. Rube Goldberg machined the game. One script was too easy. With that, that's everything. That's how you can make a game with no script. Thank you all for listening. I'm just going to take a moment to go over these points quickly, which is, this was only possible because Godot's so good at prototyping. It had all of these features built in to make us able to connect scenes so well. In addition, all of these resources like audio stream randomizer and shortcut exist to make our life easier, and there are enough of them you can take it to a ludicrous extreme you shouldn't be able to, really. If you want to play the game, there's a link in Linktree down here, and you can find it on itch. I'd probably play it. Oh, it's a web build because you can't quit web builds anyway, and I couldn't find a way to quit the game. Yeah, is there any time left, or is that it? 1 minute. Okay, one question.
Yeah, when you said that you didn't find a way to quit the game, did you consider intentionally crashing the game?
You bet I did. I spent days trying to crash Godot. It's a testament to the engineers, really. I tried some really creative stuff. I tried getting an animation player, and whenever you add a key in an animation player, it like sets a path to where the node with the function was. And I tried seeing if you could just put ... / in to climb up the tree to find a new function I wouldn't have access to. It breaks. You start accessing the editor while it's running. Yeah, I wish that was possible, but alas, nay.
Well, thank you.